Good afternoon, class. Afternoon. Can hear or not? Okay. So we discuss about my question, okay, in the chat box. So I received a few trial from the Anders, yeah, okay, Yenkiet, and also Jinyap. Okay. So, all right. So we look how we solve this question. Okay. So for the first question, okay. All right. So for the first question, I ask you, okay. So I hope all of you can see my whiteboard. Okay. So for the first, we look the Roman one. Okay. So for this one, what is the information that we can have? Okay, from the row number one. So based on the row number one, what you have? Okay, you have the x minus with the, this is the x column, y column, z column. Okay, so we have the x minus 2y plus with the z here, okay, equal to 0. So from here, okay, so you can see no information from the row 2 and the row 3. Okay, so from here, how to solve this? Okay, we cannot only let z equal to t. If you let z equal to t, you will have the x equal to 2y minus with a t. Okay, your y here still unsolved. Okay, so for this one, we need to let one more. Where is the y here is equal to s here. Okay, so from here, we can substitute the y is equal to s and your z equal to t here. Okay, so from here, we have to rearrange your x here is equal to 2s, okay, minus t. So you can say we have the negative t here, okay, all right, we have the negative 1 multiply with the t here. And your y here, what is your y? Your y here is a s. So this is the s. So the t here is a 0. And your z here, what is your z? Your z here is a t. So you can see the s here is 0 and the t here is a 1. So we look, okay, what is the correct answer? Is a 210. So based on the Anders and the 210. So for this one, Anders put the negative s. Okay, and you put the negative s is a 10 negative 1 is also acceptable. Okay, it's also acceptable. Okay, and then okay, for the how about the Yinket? Yinket also okay, correct. You also have the correct answer. Okay, and then for the Jinyap, okay, Jinyap also has a correct answer. Good. Okay, so for the question Roman 2, I look from the Roman 2, nobody answer this question correctly. Okay, so we had to discuss this type of the question, okay, yesterday. So from here, okay, we will have the x, y, and the z column. So you can see your from the row 1, you have the x minus z equal to 0. So from here, okay, you can move your z to the right hand side. You will have the x equal to z. Okay, and we can let our z here is a t. Where is our t here is can be any real number. Okay, so for this one means our x here is also t. So based on this, okay, all right, so you can see here, okay, what is your y? Okay, what is your y? You don't have any information for the y here. Okay, your y is no information about y. So this, if you have a this condition, mean this variable, okay, not involved in this system of linear equation. Mean you can put any number, okay, any value for your y, because the value for the y will not affect your system. Okay, therefore we need to put to let your y here is equal to t. Okay, where is your t here? Can be any real number. Okay, so you cannot put y equal to 0. Yeah, you cannot put the y equal to 0 because for this one, if you put the y equal to 0, means you already fix the solution for the y here must equal to 0. But based on the simplest or mathematic that you have, the row echelon form that you have, okay, is a, you can see here, you can conclude already your y here is a not involved. Okay, no need to bother about your y value. Therefore, we need to let your y as a t, whereas your t here is a any real number. So we can see here, okay, your x here is a t. So you can see t multiplied with the 1. Your y here is also t multiplied with the 1. And z here is a t multiplied with the 1 here. Okay, so this is the answer. This is, if you write the answer is a 1, sorry, is 1 0 1, this is the wrong answer because you already put the value y must be equal to 0. But actually, your y here can be any real number. So please make sure, okay, you know these two conditions, okay, how you want to have the system of linear equation for these two cases. Okay, any question? So you want to ask? Okay, okay, no problem. Can I? Any question? Or you want to ask for this? Before I move to the vector analysis. Can I? Means, so in what condition we can let y equal to 0? So what's condition? Good question. So if your y is equal to 0, means you have like this. You have the 1 here is a here. So from here you can see here, your y here must be equal to 0. Okay, but you can see here previously, this is all column for the y here is you doesn't have any information about y. Okay, so I mean, okay, you can, the value for the y here can be any number. The system of linear equation, okay, for the y variable, you can have any solution. No bother. The system of linear equation didn't bother any value for the y here. Okay, all right. How about the first row? How about x in the first row too? Which Roman is a, how about x in the first row is equal to 0? How? So for this one, okay, so if this one, maybe it's like this. Okay, so maybe you have this. Okay, okay, all right. So you have this one is a 1 here. Okay, so from here, from the last row, you can see your x here is equal to 0. Okay, right? And from the row number 1 here, the row number 1, you can have the x minus z here is a 0. So you already know the x here is 0. So I mean your z is also 0. X equal to 0, your z here is equal to 0. So for this one, how? How about your y? Okay, how about this one? How about your y? For this one. For this one means your y here is also can be any real number. The system doesn't bother your the variable for the y. So how to write down? You have the x, y, z. Okay, this one, yeah. Yeah, you have put a t, and this is the x equal to 0. Your y here is equal to t, and your z here is equal to 0. Okay, understand not? Okay. All right, Lichan, answer the question. Y is the same as t with the axis. Even though don't know, yes. All right, correct. Yeah. Okay. All right. She home. So for the second question, yes, for this case, okay, coincidentally, the x here is equal to t. Okay, previously my based on my example, my equation just now. So this is 0, right? Okay. So coincidentally, our x here is also equal to t and z here is equal to t. Okay. So mean, okay, maybe, all right, we can put the any real number. We can put any value for this one. Let's say you, for this one, let's say you have the t is equal to 2. So you have the 2 and so on for this one. Okay. This one, yeah, can be any real number. So you can, let's say for this one is a 2, this is a negative 2. So you will have the, maybe this one is not 2 lah, because for sure it's a same also. Let's say this is a 3, okay. For sure you will have the different value for this one. Okay, different value for this. Okay, different value for the this and this here. Okay, all right. Okay. So for this one, you have to make sure, okay, for the system of linear equation, if this one doesn't involve, okay, you can see this is your y here is just the one variable, one column here is no information. You just let y equal to t here. Okay. So can we put a 1, 2, 1? Okay, so this one is 1, 2, 1. Okay, so it's also no problem. Okay, for this one, if you want to 1, 1, 2, 1 is also no problem. So where is, okay, right? So you can see if the student asking, I put it, this is as 2. Okay, this one is a 1, 2 here. It's also no problem. No problem because your t here is any real number. But for the good practice, you just let the y here is a t here. Just a good practice, just let y equal to t. So we know that your y here is can any number, is can any value. So it doesn't involve with any system. Okay, so if the student asks just now, you will let this is a 2t. So you want to put the detail as a 2. So it's, for this one, is also, the answer is also acceptable actually. Okay, it's also acceptable because your y here is a doesn't effect of any system of linear equation. But you cannot put y is equal to 0. For this one, is like you already assign your y must be equal to 0. Okay, good question. Okay, sure. Any more question? Okay, so we move, we move to the vector analysis. All right, so for this one, okay, so we move to the vector analysis. So this is a vector analysis also. Okay, it's very important. Okay, for this topic, you need to do some imagination. Okay, you cannot just understand without imagine. Okay, so please try to imagine. Yeah, please try to imagine. Okay, put it in your problem here. In the 3 dimension. Okay, in the 3 dimension graph and so on. Okay, so for this one, we look first, what is a vector? Okay. Okay, so please try imagine. Yeah, you have to imagine. If you are hard to imagine, okay, it's hard for you later to answer the equation for the vector analysis. Okay, so one vector, what is the meaning for the vector? The vector here, you need to have both magnitude and also direction. Okay, so how to write the vector? So we can see we have the vector A, so we can write as a arrow on the top here. Okay, it's not must capital letter. You can have the lower case. Okay, the small letter for the A here. It's also no problem. Besides that, some of the books or notes, they use the bold. You put A here in the bold here. So if in the bold font, so you have to understand this is a refer to the vector. Okay, so what is a magnitude? Okay, magnitude. So you can see here notation for the magnitude. So let's say you want to find the magnitude for the vector A. So you can see we have the double line. Okay, we have the 2 parallel line here. So some, okay, some notation also we can use just 1 parallel line here. Okay, both are refer to the magnitude. Yeah. So don't confuse. So don't confuse if you found after this have the 2 line and some slide use the 1 line. So both refer to the magnitude. So for this one, okay, the magnitude, when we talk about the magnitude, for sure, this is the scalar. That's refer to the number, real number, right? No direction. If you refer to the magnitude, is a just carry the scalar value or real number. Okay, real number here. Okay, so make sure. Okay, so if I draw this, okay, so you can see here, we have one vector. The vector must be have a tail. Okay, so here, someone unmute the microphone. Okay, Okay. Si Pao Kyong. Okay. So you can see, for the vector, you can see we have the tail. We also have the head. Okay, means we know here that the direction here must pointing from the tail to the head here. Okay, so you have the direction. So this vector is also carry the magnitude. So we can see this is the magnitude. Okay, so we look more. Okay, so I mentioned just now, we have to put all these vector analysis in the three-dimensional Cartesian coordinate and a position vector again. Who's the Pao Kyong, any problem with you? Pao Kyong? Okay. All right. So for this one, okay, we have to put in the three-dimensional Cartesian coordinate. So you have to put this vector in the three-dimension graph. Okay, so if you talk about the three-dimensional graph, for sure we have the three axes, right? X-axis here, Y-axis here, and the pointing to the upward here is a Z-axis. Okay, so when we want to have, okay, this is a vector, so this is a black line here is referred to the vector. Okay, so how we want to represent as a vector? How we want to represent as a vector? So you can see here we have the I. You can see we have I here, have the cap on the top here. So this one is referred to the unit vector, whereas this unit vector is a follow the positive x-axis direction. Okay, so what is a unit vector? When we talk about the unit vector, where is the vector has a magnitude, okay, has a magnitude, okay, magnitude equal to 1. Okay, by the way, you just accept first for the unit vector. Okay, the notation for the unit vector, you can see you have the cap on the top here. Okay, for this, you just accept now. When we talk about the I, okay, is refer to the vector, whereas this vector is pointing the positive direction, okay, for the x-axis. Okay, and then the same thing for the J also, you can see how the cap here, this is also referred to the unit vector. For the J here is referred to the direction, okay, where is the direction for the J here is a follow the positive Y direction here. And then for the K here, it's also same thing, K with the K here with the cap, so it's referred to unit vector. So it's referred to the direction, where is this direction here is referred to the positive Z axis direction. Okay, so okay, as you know, if you want to know, okay, you already learned before, if you have this coordinate, if you want to write down this coordinate, okay, so you can put as a C bracket, right? You can put as a C bracket. Let's say I put it, this is the, let's say put it, the coordinate for the X here is a 1, coordinate for the Y here, let's say here is a 2, and let's say for the Z here, for the Z here, you have the coordinate for the Z here is a 5, they say. Okay, so you have this. Okay, so when we talk about this, okay, where I already put it, this is the head. Okay, this is refer to the head, right? This is refer to the tail. So for sure, what is this is refer to the head. This is refer to the tail. So when we talk about the position vector, this position vector is referred to the vector from origin. So for this one is a 3-dimension. What is the origin? Is a 0, 0, 0 to, okay, to the head. Head here is referred to the end point here. Okay, to the end point here. So for this one, how you want to put in the position vector? So we can put, for this one, we can put as a 1, I. Okay, 1. Okay, since the coordinate for the x here is 1, so the I here is referred to the x direction, and for the j here is referred to the y direction. So it's become the j here is a 2, and for the plus, yeah, for the k here is referred to the z direction, so it's become 5k here. Okay, so you also can write down, if you don't want to write down, this is 1, right? This is 1. So you can write down as a I plus with a 2j plus with a 5k. Just write I only. So we understood, we know that this is the constant one in front here. Okay, so if you don't want to write down, okay, if you ask me, Miss, I don't want to write the cap here. We have the cap here on the top here, right? You don't want to write down. It's also no problem. You just write down as a I. We understood. Okay, we understood. Everyone is understood. All of the I, J, K here is in the unit vector. So you can write down like this. Okay, so no need to. You don't want to write down the cap here is also no problem. Okay, so this is referred to the position vector from the origin to the head here. So after this, if the question mention what is a position vector, so you have to know what is the end point. So you have to, okay, this is the point, the position vector here is referred to the vector from the origin. So where is the origin is here to the end point, the head here. Okay, so beside that, we also, if you don't want to write down in the I, J, and K here, you also can write down in the arrow bracket. So you can see we have the arrow bracket here. Okay, for the vector. So you can see for the first, okay, this one is referred to your I. So what is your I? Your I here is 1. So write down this is 1. Okay, and the second here, in the middle here is a J. So what is your J here is a 2. Just write down the component. And the last one here is referred to the K. This is the 5 here. So it's up to you. You want to write down in terms of I, J, K, or you also can write down in the arrow bracket. Okay, but don't confuse. Don't write down in the C bracket here. If the C bracket here, this is C bracket here, is referred to the coordinate. Okay, please take note. Okay, so this is, I just give the introduction how we want to write down. Okay, how we want to write down the vector. Okay, and also how to find the position vector. Okay, position vector. So this is just the introduction first. Okay, all right. So we move to the next one. Okay, now, okay, so just now, okay, I just give you the coordinate, right? And I just give the position vector here. So you still, for sure, you cannot imagine how come I can straightly write down this vector. Where is, we can see our head point, the end point here is this. Okay, how I can straightly can give the IJK here, the position vector. So we look here. So I mentioned just now, for the I, we need is refer to the direction for the x-axis. For the j here is the direction for the j here is the direction for the y-axis, and the k here is direction for the z-axis. So look here, this is one point. So you can see this is the tail, this is the head. You can see what is the end point. So you can see we have the x is A1, the y coordinate is A2, the z here is A3. So you can see here, if you put in the three-dimensional graph, what is the A1? Your A1 here is referred to the, from the point, the origin here to the x-axis here is the A1 here. Okay, this is the A1. So means this one is referred to the, if you look this one, this is the A1. Okay, this is point 0, 0 here. Okay, so for this one, and for the A2, this is referred to the, this point here. Okay, this is the point from the A2 here is for the y-axis. So you can see the A2 here should be here. Okay, so you can see from the origin to the point A2 should be here is a point for the y coordinate here is a A2. So I mean if you look here should be the direction here, the magnitude from here to here is a A2, whereas this line here is a follow the direction for the y axis. Okay, how about the z? So you can see the z here is referred to the height, right? The z here is usually, if we represent in the 3 dimension, we refer to the height. So this is your A3 here. So you can see this is the, from the, okay, this is on the floor. Let's say you can imagine the X. Okay, you can imagine this is the floor. This is the floor. Okay, this is the floor. So the height here, this one to here is a A3 here. So you can see how we can have the position vector for the vector A. So you can see the vector A here is in the bold color. Okay, so you can write down as a on the arrow on the top also, no problem. So we can write down also arrow bracket. This is the A1 for the I element. For the J element, this is the A2 and comma, and for the K here is a A3. So we can put in the arrow bracket. So we can see here, this is the, we can represent in the arrow bracket here. Okay, so all right, so for this one, if you have the vector, okay, you have the position vector, I already mentioned. Okay, the position vector means this is from the origin to the terminal point. Terminal point here is referred to the end point, the hit. Okay, the hit point here. Okay, all right. So for this one, you can see here, okay, I mentioned just now, the I, okay, the I vector here is referred to the vector where is follow the direction for your x-axis, okay, and for the j here is follow the direction. Okay, so you can see here, this is the ijk. Okay, this is ijk. So you can see the this one, the j here is the y. The j here is referred to direction for the y-axis. So you can see this is have the 1 here. And the K here, you have the, this is referred to the, okay, this is referred to the direction for the Z axis. So this is referred to the K here. So you will ask me, Miss, why this, okay, this one, they are put it as a 1. Why we need to, why we need to put 1? Why we cannot put as a 2, 3, or 4? Because, yeah, I mentioned just now, this is how the cap. I, J, and K here with the cap mean this is referred to the unit vector. So what is the unit vector? Where is the magnitude? So now I use the notation for the magnitude. Magnitude for the unit vector I, magnitude for the unit vector J, magnitude for the unit vector K here is must be equal to 1. This is referred to the unit vector. Therefore, that's why we need to substitute this is as a 1. Okay, so how we want to know to find the magnitude for this vector? So this is the, okay, let's later we will know how we want to find the magnitude. So okay, the magnitude, I think I will move to the this one first. Okay, since all of you, so you can see okay, this is the refer to distance and also refer to the magnitude between the 2 points. So let's say you know the point 1 here is the origin. Okay, let's say you point 1 here is the origin. Okay, and the point 2 here is let's say you have the point 2 here. Let's say the point 2 here you have the unit vector I. You have the unit vector I. So you have the z. For sure, you have the x here is 1 and this is the y and z here must be 0. So from here, how to find this magnitude between the point P1 to point P2? So we have to, okay, you can see the x2 minus with the x1. So we have the 1 minus with the 0. Okay, plus, this is the square. You have to make sure this is the square. And this is the 0 minus with the 0. This is referred to the y coordinate. 0 minus with the 0 square. And the last one here is referred to the Z coordinate is a 0 minus is 0 square. And don't forget, you have to square root. Okay, that's why we have to make sure this one, you have the 1 square. So we have the magnitude here is equal to 1. Okay, that's why for this notation just now, okay, this one, this one, the unit vector I, we need to put this is as a 1 here because we want to have the magnitude for all of this vector must be equal to 1 here. Okay, so this is the, okay, we look more about the unit vector by the way. So for now, you just make sure understand, okay, if you have one vector is from the origin to the one endpoint, how you want to express in the vector. So how you can express in the vector. So this is how you can express in the vector. So for sure, you have to make sure know what is the endpoint here. Okay, so this is the first thing that you will need to know. How about the unit vector? Okay, we will learn more after this. Okay, all right. So for the next one. All right, so this, okay, so this is about the plane. Just now, we just talk about the point here. So now when we talk about the plane, let's say you have one point. Let's say this is the point. The coordinate x is the x. The coordinate y is y. And coordinate z is z. So let's say you want to have one point on the xy plane. So where is your xy plane? The xy plane here is on the floor. So you imagine here on the floor. Okay, let's say this is on your table. Okay, so what is the coordinate that you should have on this xy plane here? On this xy plane, you should have the only coordinate x and y, and your z here must be 0. So this is the coordinate on the xy plane. Okay, so this is the coordinate xy plane. So you have to know, let's say I give you the coordinate 3, -2, 0. So you know that this point on the xy plane. How? Because the z here is the 0 here. Okay, so next, how about the YZ plane? So this one is a YZ plane here. Okay, this one, the YZ plane. So for the YZ plane, this is the X. Our X here must be 0. So I mean, for this one, let's say I have the coordinate 0, 1, 5. So you can see here your X here is 0. So you know that this point here is on the YZ plane here. Okay, it's on the YZ plane. How about the XZ plane? So for the XZ plane, you can see your Y here is a 0. So for the XZ plane, so you can see this is the, okay, this is the plane that you have. All right. So for this one, this is one example. Let's say you have the X is equal to 3, your Y is 0. Okay, you can see the Y here is 0 and your Z here is equal to 5. So you can see this for this one is a no Y, is no Y, Y is equal to 0 here. Okay, so you know this point on the XZ plane. Okay, so this is the just how we want to know the projection for the one point on the each plane, for the XY plane, YZ plane, and also for the XZ plane here. Okay, so next, so you can see here this one. Okay, this is just an example. So you can see here, okay, if we look this one first. So we have this one, you can see here on the X axis here. So you can see clearly here, your X here is half the value, and the Y and Z here is 0. So same thing here, this is your point Q here is on the floor, right? Is on your XY plane. So you can see here, you have the X coordinate and Y coordinate, X equal to A, Y equal to B, and your Z here is equal to 0. Okay, and this one is referred to the point. Where is this point on the Y axis? So you can see you have the Y is equal to B, and the X and Z here is equal to 0. Okay, so same thing. So for this one, if we look the R first. So for the R here, so you can see the X here is a 0. For the Y equal to B, the Z equal to C. So you can see clearly the point R here in the YZ plane. Okay, so this is the YZ plane, is on the YZ plane here. So you can see is a YZ plane here, is a here. Okay, so for this one, for the 0, 0C, so this is refer to the coordinate on the Z axis. So you can see this is on the Z axis. And how about this? Do you have the X equal to A, Y equal to 0, and the Z equal to C. So for here, clearly, this point here is on the XZ plane here. This point S here is on the XZ plane. So where is the XZ plane? So you can see here, this is your XZ plane here. Okay, so this is just the how you can imagine. Yeah, so please try to imagine. So for this one, for sure, this is where for the point P here is a point ABC. So you can see here the point ABC. So you can see this is refer to the coordinate X. Okay, and you have to move to the here. You refer to here. You can see here. This is refer to the coordinate for the P here. And for the height here, so you can see the height here is referred to the C here. So that's why you can see the Z coordinate here is a C. So you have, this is the point P here. Okay. So next, so you can see this is how we can put in the number. So you can see, let's say you have, this is the point here is a negative. You can see here the X here is a -4. So you can see here the X here is not pointing to the positive direction, but now this is the -4. You can see this is pointing to the opposite direction, is pointing to the opposite direction with the X here. So you can see here, this is the -4. That's why you can see this is the pointing to the at the back here. Okay, so you have the -4. And this is the 3 here is refer to the Y. So it's no problem. Your +3. So you can see this is the 3. And for the Z here, you have the negative. So you can see here the direction here is the opposite direction with the Z as it is pointing downward. So you can see this is the -5. So you have this point here. Okay, so this is the 1 point. So same thing as this one, this is the X here is a +3. So you can see here, the X here is pointing toward to the positive direction, but your Y here is a negative. So you can see here, we move to here, your Y here is a -2. It's the opposite direction with the Y, okay, positive Y here. So it's a -2. And your Z here is a -6. So you can see here, this is the pointing to downward. You have the -6 here. So you have, this is the point here is a 3, -2, -6. So, all right. So this is just about the point. So when we talk about plane, okay, when we talk plane, when you have the Z is equal to 3, where is this plane in the 3-dimension graph? So if you have the R here is a R power of 3 here is referred to the, okay, whereas you have the graph here in the 3-dimension graph, okay, whereas you have the 3 variable, should be, you have the X, Y, Z. Therefore, you can see you will have the 3-dimension graph here. So just take note, when we have the R, the notation R power of 3 here means, yeah, the graph will be in the 3-dimension graph. So how we want to put this plane? So you can see here, we have the point here. This is a coordinate here is a 0, 0, 3. So you can see here, you have the blue plane here. The blue plane here is referred to the plane Z equal to 3. So you can see this plane here will cross, okay, will intersect the point 0, 0, 3 here. They are parallel. This, okay, plane, they are parallel with the, okay, with the XY plane. Okay, they are parallel with the floor. Okay, they are parallel. Okay, means they are same direction. The parallel means the same direction. They are, okay, they have the, this is a, okay, they are same direction with the floor here. Okay, they are parallel with the floor. So how about the Y equal to 5? So you can see for the Y equal to 5, we have the plane here. Where is this plane here? Will intersect at the point 0, 5, 0 here. So you can see here, this plane is a follow the direction. You can see they are follow the direction of the X axis. Okay, they are follow and the direction as a x-axis. Okay, so this is the plane y. Okay, and if you want to convert the plane y here into two-dimension graph. So you can see this is the r power of 3, but this is the r square here. So mean this is in the two-dimension graph. So you can see here, you will have, this is the point here. Where is the point here? Is a 0, 5. So you can see here, this will not have the plane, but this is become the line. Where is the line here? For the y equal to 5 here, yeah, parallel with the x-axis. Yeah, parallel with the x-axis. Therefore, you can see here, if we put in the three-dimension graph, so this plane also, yeah, parallel with the x-axis. Okay, so please take note this one, yeah. I'll try to imagine. Okay, so next, okay, this is example. Okay, how we want to put one point. Where is this point must satisfy these two equations. The first one here is x squared plus y squared equal to 1. So what is this point? This is what is this equation? Hami, what is this equation refer? What equation that you will have for this? Hami, what equation? What equation? What is the equation that you have for this one? Hami, don't know. Where is Hami? I think someone want to unmute the microphone. Want to answer? Yes, circle. Good. Li Chen and Aaron. Circle with the radius 1. Good, Aaron. Okay, so this is the equation, the general equation for the circle. What is it? X squared over r squared plus with the y squared over r squared equal to 1. Okay, the r here is referred to the radius. For sure, if compared to this one, means your radius here is equal to 1 square, right? So means the on the denominator here is a 1 square, and this is also 1 square. So you will have the circle. Where is this circle here? Is the radius here is equal to 1 here. Okay, so the question also have the as a one this point here must satisfy. Where is this point must at the z plane. So you can see you have the circle here is before this is on the floor, is before this is on the xy plane, but now is a move to the up. Okay, is a move to the up. Where is this circle here is become on the z plane. Where is the z plane as a at the z equal to 3. Where is the z here is equal to 3. So you can see this one is a z plane, right? Okay, so z equal to 3, right? So you can see you have the circle here. Where is the radius here is equal to, the radius here is equal to 1 here. Okay, so you will have, okay, the point here. Where is, this is the point here. Where is the point here on this circle? Where is this point is also on the z plane. Okay, and the z plane z equal to 3. Okay, all right. So this is how we can see here the point lies, okay, in the horizontal plane. Where is this horizontal plane here? Okay, is a plane z equal to 3 here. Okay, so this is just example. Try to help you to imagine. Okay, so for this one, we move to this. So we want to find distance. Okay, previously is about the position vector, right? I put it the point P1 here as the origin. Okay, so if you have the point P1 here, is let's say is 1, 3, 2, okay, and you want to have, okay, let's say this is point 1, 3, 2, and you have the point 2 here, is a 4, 5, 6, let's say, okay, let's say this point. Okay, so you want to find the distance, okay, you want to find the distance, this one, oops. You want to find the distance between here to here, the point P1 to P2. So what is the formula? So you can see, first of all, we look the notation. So you can see, we look the notation P1 to the P2, you have the parallel line here. So if you want to put a double line, is also no problem. So it's referred to the magnitude also, is referred to the distance also. Okay, how we want to put here? Okay, how we want to have this magnitude? So we look at the example here. We have to put the square root everything. For the first one, we have to look the point P2. Point P2 here is referred to the point X. Okay, so we have the 4 minus with the 1 square, and this one is the second term here is a 0.1 is a 5 minus 3 and square, and this is the last one here is referred to the coordinate z is a 6 minus 2 is the square here. Okay, so if you ask me, Miss, I don't want to put the x, the point number 2 in front. I want to put like this. I want to put the 1 minus 4 square plus with the 3 minus 5 square. I want to put the point number 1 first in front. Okay, and 2 minus 6 square here. Okay, you want to put like this. Okay, you want to put the point number 1 first. Okay, this is the point number 1 first. No problem. Okay, because later you will square, right? If you square, for sure you will have this value. Okay, will be, if you have the negative, for sure, if you square, you will have the positive. And you will have the same value as you put the x2 and y2 and z2 in front. Okay, don't worry. Both steps are acceptable. Okay, all right. So for this one, yeah. Okay, so if this one, for this case, you have the x, y, z coordinate. For this one, you can see you only have the x and y. So you can see you only have two terms. You only have the two terms. So you don't have the z. You don't have the z coordinate. So it's okay, just write down x2 minus with the x1 and y2 minus with the y1 here. Okay, square. All right. Okay, so next, this. Okay, the question asks to find the distance between the point E to the point C. So you can see here, this one, yeah. So for this one, I use the, okay, the notation here. I can put this one, you can see here, this is the point, this is the distance here as a B. So you can see here, why we can have the B here, because you can see here, the X coordinate for the point A and point B, point A and point C here, same. Y coordinate also same. Okay, the only difference here is the point Z here. That's why you can see I have the straight line here. Okay, we can have the, imagine this is a point C and a point A here in the straight line here. Okay, all right, so for this one here, how we want to have the distance? So you have the square root. So you can see here for the first one here, 2 minus with a 2, okay, square, plus 3 minus with a 3 square, plus 5 minus with a 1 square, and don't forget square root everything. So you will have the square root 4 square. You will have the magnitude, okay, the distance between C and A here is equal to 4 unit. Okay, so this is just division actually for you. This one is a unit vector. So previously I already introduced for you I with a cap, J with a cap, K with a cap here is referred to the unit vector. What is the definition for the unit vector? Where is one vector has a magnitude. I repeat again, yeah, because this one you will use in the topic 3 also. Topic 3 you will use the unit vector also. The vector has a magnitude equal to the one unit only. So how we want to find unit vector? So the question will give you the vector A. So this one, 4i minus 3j. So this one, I put it, convert in the ij term. And this is your vector B here, this is the I plus with a 2j plus with a 2k. Why I put it the arrow bracket? No arrow bracket here. Okay, so the question asks to find the unit vector A. So you can see your A here, previously we have the arrow, but for the notation for the unit vector, you have the cap here on the top here. And the question also asks you to find the unit vector B. So what is the formula to find the unit vector? You need to divide the vector A that you have with the magnitude. Okay, with the magnitude for the vector A. So same thing here, you have the vector B, you need to divide with the magnitude for the vector B here. Okay, so for this one, okay, we look first for the first one. So what is a vector A? So you can see the vector A here, we can put in the arrow bracket 4i minus 3j. So this is the on the top here. Okay, what is the denominator? The denominator on the below here, you have to divide with the magnitude. So how to find the magnitude for this vector A? You have to square root. Okay, this is the element for the I unit. This is the refer to the x. So this is the 4 square plus with the, this is the in bracket negative 3 square. So you will have, okay, the, if I put it, this is a become, okay, square root 25, right? It's become square root 25. So the square root 25 here is equal to, okay, 5. Okay, is equal to 5. So mean you have to divide, okay, this one for the I element 4 divide with the 5. So it's become 4 over 5. Okay, and this one for the j here is a negative 3 over 5. So please try, please find this the magnitude for this unit vector here. So you have the square root 4 over 5 square. You can try. Okay, you can try negative 3 over 5 square. What is the magnitude that you have? You must have the magnitude must be equal to 1. This one. Okay, so this is correct. This is referred to the unit vector. So the answer here is you can put also in the I and j term 4 over 5i minus 3 over 5j. Okay, this is referred to the A unit vector. Okay, it's up to you. You want to put the arrow bracket or you want to put in the ij term. Okay, all right. Okay, so for the B, here, so you can see you have the vector B. This is the vector B divide with the magnitude. So you can see this is the 1 square plus the 2 square plus 2 square. You have to square root everything. Okay, so you will have the answer here is what is this? This is 4 plus 4 is a square root 9, right? Or the magnitude for the vector B here is a square root 9. This is referred to 3. So you have to divide 1, divide with the 3. You have this is element for the I. 2, divide with the 3. You have the J, and this is for the K. You can have a try square root 1 over 3 square plus with the 2 over 3 square plus with the 3 over 3 is 1 lah. Is 1 square. You will have, this one is not 3 lah. This is a 2. Sorry, this is, please make correction. Okay, this is a 2. Should be 2. Okay, this is a 2 over 3 square. You will have the magnitude here is equal to 1. Okay, please make sure, lecture I mentioned in the topic 3, you need to find unit vector too. Okay, in the topic 3, you also need to find the unit vector. You also need to use the unit vector. Any question? You can, All right. So next, okay, this is an example. So the question asks, find the distance between the point P to the point Q. So you can see here, all right? So we can write the notation P to the Q, all right? So you can write down like this, and you have 2 lines here. So you want to put the double line is also no problem. Okay, so for this one is what, how do you write down, how you want to have this, find the distance. So you can see here, we look the x coordinate 1 minus 2 square. Okay, negative 3 minus with the negative 1. That's why we have the plus here square. And this is 5 minus with the 7 square here. So you will have, okay, you need to square root everything. And you have the 3 here. Okay, I mentioned if you want to write down 2 minus with the 1 square is also no problem. You want to put this is the, should be this is the negative 1 minus with the negative 3 is also no problem. You want to have the square here. And this one is a 7 minus with the 5 square is also no problem. You will have the same magnitude is equal to 3 here. Okay, it's no problem. Okay, all right. So now this is the Roman 1 this time. Okay, so next, the question asks to find unit vector for this vector PQ. Okay, this is very important. Okay, the question will ask you find the vector PQ. Okay, all right, before we want to find the unit vector, okay, what is a unit vector? This is the, I put a vector PQ. Where is the unit vector? You can see we have the cap on the top. We need to divide the vector PQ with the magnitude, right? With the magnitude for the vector PQ. So before we find the unit vector, this unit vector, we need to find the vector PQ. Okay, so if I ask you to find the vector PQ, okay, you have to make sure for the I element here. Okay, for the I element here, you have to start your X coordinate here with the using the coordinate Q. Okay, using the coordinate Q. Okay, and minus with the coordinate P. Okay, and then this is for the I element. For the J element, same thing. Use the coordinate for the Y coordinate Q here. The coordinate for the Y coordinate Q minus with the Y coordinate P here. Okay, all right. And then for the for the K here, this one is a K. So for you confused, this is everything is in the comma. Yeah, this is a comma. Yeah, this is the comma. For the K, you have to start with the Q. Okay, Z coordinate of Z coordinate, Z value for the coordinate Q minus with the Z coordinate for the point P here. Okay, so if you write down like this, if you write down this is the X P minus with the X Q. Okay, you can see here. Why is the different here? Why is the different here? You put previously you put the Q in front, but now you put the P at the back here. Okay, and then this is referred to I element. You put the for the Y here, same thing. You put the YP minus with the YQ. Okay, and for the K here, you put the ZP minus with the ZQ. Okay, this is not referred to the vector PQ. Okay, this one is not referred to the vector PQ. Okay, but this is referred to the vector QP. If the question asks you to find the vector PQ, but you give the vector QP wrong, yeah, 0 mark. I will give you 0 mark, no grace mark. Okay, for this, I straightly 0 mark here because I don't ask you to find the vector QP. I ask you to find the vector PQ. So please take note. Okay, please take note. Okay, so you the tips here. Just look the point at the back here. The point at the back here is Q. So you start everything for the first term for the each component here. Start with the coordinate Q here. So this is the highlight here. So you can see this one is start with a P. Therefore, you can see this is referred to the vector QP, not the vector PQ here. Okay, so please take note. Okay, so for this one, okay, so this is the vector PQ. So you can see here is 1 minus with the negative 2, minus with the 2, sorry, you have the negative 1, and this is the negative 3 minus with the negative 1 here. You will have this is the negative 2, and for the K component is a 5 minus with a 7. You can see this one, you have the negative 2. So this is referred to the vector PQ. So you want to find the unit vector. So you can see we have the cap here on the top here. So this is referred to your vector PQ. Write down on the top. You need to divide with the magnitude for the vector PQ. So you can see this is the unit vector for the vector PQ. So I think I will stop here. So already okay, exceed the time. Okay, so please take note. Okay, all right. Okay, please make sure, please remember we have the replacement class on this Saturday. So please attend. Okay, I will explain more about the vector analysis. This topic is also very important. You have to make sure, okay, you attend the class. Okay, so because I will do demonstration. I will open my camera and I will help you try to imagine, help you to imagine, okay, in the 3-dimension graph about this vector analysis, this topic. Okay, so please attend the class on this Saturday from 9 to 11. I think that's all. I need to move to the another class. So make sure please scan your QR code. Okay, I think that's all for today. Okay.